All right, here we are for 5.2, which is looking at natural selection, the driver for evolution. So sometimes they refer to this as the mechanism for evolution. Many of us have already heard of natural selection and we're probably pretty comfortable with it. We just need to be able to explain how does natural selection lead to evolution. So here we go. So firstly, we need variation and competition. And so all organisms have different characteristics. And we've seen this before where why do they arise? These different characteristics, this variation. Things can happen, mutations can happen naturally. Meiosis is always producing variation in gametes. And then obviously we have sexual reproduction in many organisms, and that's going to result in a different combination of alleles, which will also cause variation. As this variation happens, some organisms are going to be better suited to their environment because of these variations, and over time, that could be an adaptation of a species that arises. All organisms in an environment are going to overproduce their offspring, and that means that there's going to be competition between individuals. And those individuals with better characteristics to the environment, better suited to the environment, are going to survive. And when they survive, they are going to pass on their genes better. They're going to mate more and mate more often because they're going to live longer, and their babies are going to have their genes with their variations in them. And those organisms, the babies, will then pass on those same variations to their offspring, assuming that they're still well suited for the environment. Slowly, over many generations, the traits that are better adapted to the environment are going to become the norm in the population. And we can see this happening with bacterial resistance to antibiotics. We just see it happening over the last 50 years, 100 years, because bacteria reproduce so quickly. So usually in, let's say, mammals, this would be over 100,000 years or 200,000 years. Whereas in bacteria, we're seeing it happening over 70 years. So this is the peppered moth, the white one. He's kind of or she is kind of an icon of natural selection. And so the backstory on the peppered moth is that the white and gray one here used to live on the trees in the UK. And with the Industrial Revolution, a mutation happened in the genes, and then the black one started to become the norm. And this was because birds couldn't actually see the black one. The black one on the trees because of the soot, the dirt on the trees because of the Industrial Revolution. Whereas before the Industrial Revolution, the trees all had lichens on them. So the spotty peppered one hid better on the trees. And both of these moths hide in the daytime and fly at night. And so the animals, interestingly, that still hunt these moths in the daytime are the ones that arose, they evolved before this mutation occurred. And so what ended up happening with the peppered moths is that the white ones were so visible on the trees that the birds just ate them up. They obviously didn't pass on their genes, but the black ones survived. And the BBC was reporting on an article recently that they did a study on the genes and discovered that this mutation occurred in 1819. I think it's completely amazing that they were able to pinpoint it to a year where this mutation was like, poof, there it is. Okay, so to summarize here, natural selection drives evolution. You have a good trait for the environment, you survive better, you reproduce more and more often, and so your babies have all of your genes, and this trait becomes the norm over a long period of time, maybe 10,000 years. And then evolution has happened. Fantastic. That is all for 5.2.